This is the video lecture for the topic binding. This is from the second unit of Principles of Programming Languages. Binding is the act of associating properties with names. In programming, binding time is the moment in the program's life cycle when this association occurs. In general, binding is the association of attributes to its entity or operation to its symbol. Time of binding is called as binding time. There are many different binding times are available in the programming. First of all, language design time is bound to the multiplication operation. For example, pi equal to 3.14. This will be designed in the language design time. Language implementation time. A data type such as int in C is bound to a range of possible values. Compile time. In some of the bindings will be happening in the compile time. For example, a Java variable is bound to its type during the compilation time. Link time. A call to the library subprogram is bound to the subprogram code during the link time. Load time. Load means loading. Loading of program in the main memory during the execution. This is called as loading. Some bindings will be happening during the load time. For example, a variable is bound to the specific memory location. Runtime. Some of the bindings will happening in the runtime. For example, a variable is bound to the value through an assignment statement during the runtime. A local variable of a Pascal procedure is bound to a memory location during the runtime. For example, count equal to count plus 5. The type of count is bound at compile time. The set of possible values of count is bound at compiler design time. The meaning of the operator plus is bound at compile time when the type of its operands have been determined. The internal representation of the literal 5 is bound at compiler design time. The value of count is bound at execution time with the statement. Binding of attributes to the variable. Static and dynamic. Static. If binding occurs before runtime and remains unchanged throughout the program execution is called as static binding. If binding occurs during the runtime or can change in the course of program execution is called dynamic binding. Type bindings. Before a variable can be referenced in a program, it must be bound to a data type. It is important to identify how the type is specified and when the binding takes place. Variable declarations. There are two types, explicit declaration and the implicit declaration. It is a statement. Explicit declaration is a statement in a program that lists variable names and specifies that they are a particular type. Implicit declaration means of associating variable with the types through a default conventions rather than declaration statements. First appearance of a variable name in a program constitutes its implicit declaration. For example, this will happen in the Python. In Python, we no need to declare the variables. Both declaration create static binding to the types. Most current programming languages require explicit declaration like Perl, JavaScript and ML languages. Earlier languages have implicit declaration. For example, in Fortran, if not explicitly declared, an identifier starting with I, J, K, L, M, N are implicitly declared to the integer, otherwise to real type. In Fortran, variables that are accidentally left undeclared are given default types and leads to errors that are difficult to diagnose. Some problems of implicit declarations can be avoided by recurring names for specific types to begin with the particular special characters. Dynamic type binding. Type of a variable is not specified by the declaration statement, nor can it be determined by the spelling of its name. Type is bound when it is assigned a value by the assignment statement. For example, these will be happening in the JavaScript and PHP. In JavaScript, let us have the statement list is equal to some values, list of values. List is a single dimensional array of length 3. For another type, we can declare like the list equal to 73. List is a simple integer. Type inference. ML is a programming language that supports both functional and imperative programming. The type of an expression and the variable can be determined by the type of a constant in the expression without requiring the programmer to specify the types of the variable. For example, fun circum r equal to 3.14 star r star r. Here circum is real variable. Fun times 10 x equal to 10 star x times 10 is a integer variable. Fun is for function declaration. Fun square of x equal to x star x. So if called square of 2.75, it would cause an error. It could be rewritten as fun square of for the real and for the other variable types. Storage bindings and lifetime. Allocation is the process of taking the memory cell to which a variable is bound from a pool of available memory. Deallocation is the process of placing the memory cell that has been unbound from a variable back to the pool of available memory. Lifetime of the variable. Time during the variable is bound to a specific memory location. According to their lifetimes, variables can be separated into 4 categories: static, stacked dynamic, explicit heap dynamic, and implicit dynamic. Static variables are bound to memory cells before execution begins and remains bound to the same memory cells until the execution terminates. Stacked dynamic variables. When declaration statement is elaborated in runtime. For example, a Pascal procedure consists of a declaration section and a code section. The local variables get their type binding statistically at compile time, but their storage binding takes place when that procedure is called. Storage is deallocated when the procedure returns. Explicit heap dynamic variable. These are the nameless variables. Storage allocated or deallocated by explicit runtime instructions. This can be referenced only through the pointer variable. Implicit heap dynamic variables. Here the storage and type bindings are done when they are assigned values. And runtime overhead of allocation and deallocation is the disadvantage. Advantages are highest degree of flexibility. So that's all about the topic. Thank you.